Hello everyone, Assalamu alaikum. My name is Hassan Parwani and today my topic is Cardinality and my course name is Semantic. Moving forward with Cardinality. Cardinality is generally, hello everyone, my name is Hassan Parwani and today my topic is Cardinality, which is from the course of Semantic Web. Alright, let's get started with Cardinality. Cardinality generally refers to the rules of data. Rules of data in a sense that if you are somehow defining the rules of data in a database, or you can say that in any ontology, or you can say that in semantic web, there are certain amount of you can say that stages you have to go through, in which cardinality is one. In this topic, we are discussing that topic, that is cardinality. All right. So let's move forward with this. And you can simply understand it by saying that there is four type of amount of data, or you can say that four types of data we use in database. That is required data, optional data, minimum number allowed, and the maximum number allowed of data. All right. So if your data states that your description can include only and only one title for the resource, that is expressing cardinality. In this way, we express cardinality. Let's take an example of this from my this slide. You can see that there is a set of A and A and A, and the three of them are different from each other. Let's refer A to cricket. All right. So you want to play cricket, but you don't have any bats. So the set of cricket, because you don't have any bats, so cricket, you cannot play cricket. All right. Because to play cricket, you have to own a bat or you have to have a bat, but you don't have a bat. So in this way, you can't play cricket, and the cardinality of playing cricket would be zero. The possibility, basically, would be zero. All right. So let's take another example. If you want to play cricket and you don't, and you have two bats, because it's not defined, it's n number of elements, and we are defining it that it is n number of elements. All right. So if you have two number of bats, two bats to play cricket, so you can play cricket with two bats. So the cardinality would be one, because you can play cricket. In other way, if you don't know how much bats you have or how well do you want to play cricket or how much you want to play cricket, in this way the criteria of playing cricket would be infinite. Let's take an example side towards the notations. That is, the cardinality of a set A is denoted by A determinant. That these two bars we use in mod as well and for determinant as well. Not in mod exactly, but in determinant as well in mathematical terminologies. And in this, we use it to determine the cardinality of a set, or you can say that of a class. Alrighty. So this is example, or you could say that this is a definition between the, if you are providing two of the classes, let's take an example of A as a class 1 and B as a class 2. All right. And we are building a relationship between them. So they both have to be the same number of elements to correspond with each other. All righty. So 1 is corresponding with A, 2 is corresponding with A, 3 is corresponding with I, and 4 is corresponding with O, and whereas 5 is corresponding with U. So overall cardinality of set B would be, because they all are corresponding with each other, and A is the first one and B is the second one. So we are taking the cardinality of B because all of these elements are going forward towards B, would be 5, because they all combine themselves and make it one. All right. If A and 1 are corresponding with each other, they are making it to 1, okay, instead of 2. So this we are good moving forward. Actually, we are moving forward pretty amazingly. And we are about to have our second last slide, I guess. In this way, absolute value, what is the absolute value? In physics and mathematics and in any term where we use absolute, it means it rather be or it can be greater than 0 or it can be less than 0. Samely, or you can say that similarly, in this point of view, or you can say that in this topic, we also have the same terminology, we have the same understanding of absolute value, where we have two of the values of a same set of cardinality, where we have if A is positive, it would be greater than or equals to 0, because 0 is the origin point of anything. This is a basic thing we understand from geometric interpretation. I have written it in this slide below. You can see that. And if A is in negative, so it is obvious that it would be less than 0. In this way, the graph would be minus. All right. Let's take an example of this. Let's see. So you're seeing that this is an origin point which is referring to 0. 0 is an origin point. All right. If x is, or you can say that because x is denoted here as axis, so we are defining it by a, right? If a is traveling from 0 towards right, all right, towards right, and these are the positive points given below, and it travels through 1 2 5 1 2 3 4 to 5. And if b is traveling, or you can say that, sorry for the grammar, if b is traveling from 0 to backwards, like -1 -2 till -3, so the cardinality of traveling between 0 to 5 would be 5, obviously, because it travels about 5 numbers. All right. And the cardinality of -3 would be 3, obviously, because it travels from 1 to 3, 0 to 3, and it includes for about 3 number of points. So it doesn't mean, this example really states that it doesn't mean whether it's whether your cardinality is or you can say that this your source is negative or positive, but the cardinality couldn't be negative. This example states that if your number is negative, it doesn't state that your cardinality would be negative. Cardinality can never be negative. It would also be in positive, either it would be 1 or it would be 0 in terms of semantic web. All right. Thank you so much, guys. Thank you for listening, and thank you so much for your kind attention if you're watching this. Thank you so much, man, for giving this opportunity to me to represent it myself, because no, nothing else. Thank you so much.